This week on the Internet Computer Weekly podcast, I'm joined by Dominic Williams, the man, the legend, the tech revolutionary. Dramatic enough? Or maybe should I tone it down? What do you think, Dom?
Sounds nice. I like that. Well, I'll keep it. Thanks.
Okay. Hey, so 22 minutes ago, you tweeted, "Big news, I just gave the instructions to directly integrate the networks using chain key cryptography. Internet Computer and Ethereum smart contracts will now be able to directly interoperate. No hubs, no cloud, no BS. One word, transformative, smiley face, DFINITY symbol." Can you tell us what this tweet means? Who have you given these instructions to? What is chain key cryptography? And let's dive into a bit what it means for internet computer canisters and Ethereum smart contracts to interact.
Yeah, so first of all, I mean, the internet computer blockchain runs using this cryptography framework that we call chain key. People refer to it as chain key systems, chain key technology, but that's basically how the internet computer runs at web speed and how it's able to scale out its capacity without bound and so on. So for example, with a traditional blockchain, if you want to interoperate with it, for example, send it a transaction or, interrogate it in the case of Ethereum, you want to find out how a smart contract responds to a call. You'd run a local node, and that local node essentially downloads a copy of the blockchain, and you interact with that. And that node will make sure that the copy of the blockchain that it maintains is valid, right? And so that's how you're able to interoperate with the blockchain. The internet computer, obviously there are problems with that though, because if you want to download the entire Ethereum state, you're going to be downloading about 5 terabytes or something, I think it is now. And then, if you want to just get the latest state and the past states, it's like 400 gigabytes. And then even when you downloaded it, there's a lot of sort of time must be spent like processing all this data to create it for the node is bootstrapped. And to try and deal with these, the hassle of having to do that, like Joe at Consensus has created that thing called Infura, and he just runs, hundreds of these nodes on other people's behalf on Amazon Web Services, and people when they create a website interact with that. So the internet computer uses a lot of like advanced new cryptography, and I won't try and describe it here. I mean, there are papers out there. You get back to early copies of them on my Twitter and so on. And it is moon math. It's very non-trivial. But all that'll be interesting to people who understand cryptography. So the advance with it is that blockchains get their own chain key, which is equivalent to a public key. So with public key cryptography, for example, I could create a key pair, and Arthur, I could give you my public key, right? And in the future, like I could use my private key that corresponds to that public key to sign a message, right, and send it to you, and then you'd be able to use my public key to check that it really was me that signed it, right? And obviously public key cryptography has been around for a long time, and that's the basis of foundation of how Bitcoin works, right? Core foundation. So the internet computer basically gives blockchains these things called chain keys, and which is like a public key, and the blockchain signs its interactions, right? And you can all you need to do is just check that the signatures on these interactions correspond to the chain key. And that tells you not only that the interactions are valid, but the actual blockchain that's interacting with you is also valid. So, if you think about like how you do it today, like you're going to get this node and you're going to download, say, for example, all of Ethereum's history or current state, however you want to do it. And it's either hundreds of gigabytes or terabytes, and you're going to process all that stuff. It's a very heavyweight thing. With a chain key blockchain, all you need is a 48-byte chain key, and that's enough to validate your interactions with it, and also the blockchain's valid. You don't need to download all its old blocks and current state and so on and so forth. So they work in a very different way, and that's obviously a big help was a big help to us in creating this scalable blockchain, because within the blockchain, within the internet computer network, actually, it's composed of lots of subnet blockchains. And these subnet blockchains are put together by this governance system, the network nervous system. Each subnet blockchain has a chain key, right? And this enables them to interoperate with each other directly. They don't need to download each other's blocks to know they're valid. And in fact, this network nervous system thing that controls the whole network also lives on its own subnet blockchain. And it has a chain key, and that's like the master chain key. And so no matter how big the internet computer network gets, and complex systems will have smart contracts, all over that network, right? Although, the subnets are invisible to smart contracts, but you as a user, like an application running in a web browser or an app on a smartphone, whatever it is, when it's interacting, in order to interact with that huge network, all it needs is the chain key of the network nervous system, and that's enough. And similarly, inside the network, all of these subnet blockchains respond to the commands of the network nervous system, subnet blockchain, which they can validate because they've all got its chain key. And basically, the network nervous system tells them what the chain keys of the other subnets are, so they can directly interoperate without downloading each other's blocks. And so this is revolutionary, and that's why it can scale out. It's obviously vastly more efficient. And there's much more to it than meets the eye. I mean, one of the really cool things is that the chain key, the public key, stays the same even as the membership, the nodes creating a blockchain, a subnet blockchain change. So, for example, you could have some subnet blockchain. Let's say, for example, currently the network nervous system subnet blockchain is hosted by 28 node machines that are run by 28 independent node providers in 28 different data centers in different geographies around the world, so or something like that. I think, sometimes those node machines go wrong, right? Or potentially a node provider could get slashed because their nodes aren't behaving properly. And so some nodes will get removed either because of mechanical malfunction or because of malice even, or just incompetence, and they get slashed. And then new nodes will be put in to make sure there's a sufficient level of redundancy to host the network nervous system. But even as these nodes are being removed and added, even though there's like dynamic membership, the chain key stays the same. And this really is revolutionary.
And this is made possible by threshold cryptography, correct?
Well, yeah. I mean, everyone probably knows who's followed me. I mean, I'm a big fan of BLS cryptography.
Yeah.
And that's where it all started off. Back in 2015, I think I started talking about threshold relay and how that could generate, an unmanipulable, unstoppable, and unpredictable stream around numbers in a decentralized network without running a consensus protocol. And then those random numbers could be used to drive, as I showed later, other protocols like probabilistic slot consensus, and then even other stuff. So I mean, if you dig down into the internet computing, you'll find a lot of BLS going on. And in actual fact, chain key, and there's some specific new cryptographies. So for example, there's a thing called non-interactive DKG, which allows parties in a decentralized network to set up a BLS threshold sharing scheme in a single step, right? Which is extraordinarily powerful, and that's that works using advanced zero-knowledge proof techniques and things like that.
So where does this all come to?
It's very technical. You probably don't want to go too deep into it.
But where does this all connect to Ethereum?
Well, so I mean, the internet computer is a completely new kind of blockchain, first of all, right? And it has these capabilities, and but it took many years to develop it. As you know, I mean, I was very close to the Ethereum project in the early days, and deeply inspired by the sort of world computer ideas, and smart contracts and things like that. Many years ago. And the truth is, without Ethereum, there'd never been an internet computer, and that's really what inspired me. So, but they're different things. They're very different things. I mean, the internet computer is all about speed and efficiency, and it runs on a sovereign physical, uses some new system no one's really given a name to yet, which looks in some ways resembles proof of work, in some ways resembles proof of stake. Ethereum is, at least as far as currently, it's traditional blockchain proof of work, although it'll migrate to proof of stake. But they're always going to have very different properties. And, they do pursue slightly different visions. You can run a block making Ethereum node from your bedroom if you're willing to credit node with some decent graphics card and pay a big electricity bill. Whereas the internet computer is designing it runs on special node hardware that's installed in these data centers. They're sort of different things, and there's a kind of chasm in terms of performance between these networks that's just never going to be closed. It's just the chasm's too big. Currently a gigabyte of data in an Ethereum smart contract costs you, the current price is $100 million as we speak. It's extraordinary. On the internet computer, the result of chain key and many other innovations, looking at about $5 a year, and that's constant. It's not volatile. The actual price of computation and persistent memory paid in cycles is approximately constant. So, and also the internet computer does all kinds of other stuff. It's web, smart contracts and web speed. It serves. You can have smart contracts serve web experiences directly into browsers. So you actually get this benefit of end-to-end blockchain security. So currently, for example, this is a kind of feature that Ethereum might want to use. But, currently on Ethereum, like you credit Ethereum debt. Basically, you create the website in the cloud on Amazon Web Services, and then all your users interact with that. So if you're a user of one of these things, you have to trust that. Whoever's operating that website is honest. Because if whoever's operating that website is dishonest, they can do all kinds of bad things, right? Like they can serve you faulty wallet code and all kinds of horrific things. So you got to trust the website operator. You got to trust Amazon, because obviously they could tamper with the website, and you got to trust that the website operator, whoever has the Amazon Web Services account, hasn't been hacked. So it's very insecure. And I also feel like blockchain should be sovereign and we should be running off its own network, not on cloud and so on. So internet computer smart contracts serve web and create this end-to-end security, blockchain security for users. That's something that Ethereum DeFi contracts could use, right? So there are lots of potential synergies between these networks. And at one stage I used to call, kind of jokingly, the internet computer DFINITY like Ethereum's crazy sister. So there's a sort of history there. So it's kind of, I think, the apt to combine them and produce something much more powerful. Now, the reason we started talking about chain key cryptography is that provides the foundation of how to do this. So essentially, and without getting into how chain key cryptography and the whole framework works, it's very complicated. It's lots of different components. But if anyone's interested in knowing how some of the components work, should go look up the non-interactive DKG and key resharing paper. It's very interesting, but it's beyond the scope of what we're going to talk about here. So, what chain key, but at a high level, what this framework will allow us to do is to have smart contracts. Canisters on the internet computer are really smart contracts, right? Canister is just a name for a particular kind of smart contract, right? So, internet computer smart contracts will be able to create Bitcoin transactions and Ethereum transactions. Sign them, yeah, without actually having a private key. Yes. So yes. So basically, smart contracts on the internet computer will be able to directly call Ethereum smart contracts. That's already possible. So that's
how does that work?
Honestly, it's essentially. I mean, it's not as high performance as the BLS stuff that we do, but you can do threshold ECDSA. So it's obviously, it's not inexpensive, but you got to remember, I mean, computation on the internet computer is way less expensive on Ethereum. So, it's not making a call to Ethereum will be very expensive compared on the internet computer compared to making it a call to another local smart contract, but you have to remember that. I mean, Ethereum calls are already a million times more expensive anyway. It's like sometimes I don't know what it is now, like $50 a call. So it won't be. I mean, when I say expensive, I probably like 25 cents or something. I don't know, 20 cents. We'll have to wait. I don't know. You have to wait for the cryptographers to come back and tell us, but it might be even cheaper than that. So, you know, you can create smart contracts on the internet computer that can call into smart contracts on Ethereum using, and it'll be very easy for smart contract developers to do. All the complex work will be done behind the scenes by our cryptographers. So that means, I mean, just starting off, I mean, well, that means, okay, so you could create like, you know, websites that are served from the internet computer, right? That take input and then send that input to Ethereum. So this is just the beginning, by the way, just hang with me. So, you know, now, first of all, obviously, if you're an Ethereum dApp or an Ethereum DeFi system, whatever it is, finally, you can get rid of the curse of big tech cloud, right? Finally, you get rid of this, you know, hideous grumple on the beautiful face of decentralization. Finally, you can give people end-to-end blockchain security. You have to trust the website operator, the Amazon Web Services, and that they haven't been hacked. So yeah, first step, let's get a website running from internet computer smart contracts. And then when that, you know, when people, you know, the end users interact with that, that will talk back to the internet computer smart contract, which will then, you know, forward the relevant information on to the Ethereum smart contract. So that's already a huge improvement, of course. But, you know, we want to have two-way calling. It'd be very boring if we just went in one direction. So step one, which I just described, which is the thing that cracks the problem open, right, is made possible by Moon Math, new cryptography. And that's our job to solve. But we also want calls to come back the other way. And actually, it's pretty straightforward. So what we'll have to do is create a relay that collects the latest Ethereum blocks and then copies them onto smart contracts on the internet computer. Now remember, the internet computer isn't like a normal blockchain. It runs at web speed, it has unlimited capacity, etc. So, you know, we can take all those Ethereum blocks and we can stick them on the some, you know, smart contract on the internet computer blockchain. And that smart contract, internet computer blockchain, will validate the blocks itself. And not only will it validate the blocks, and it certainly needs to keep the tip of the chain, it will, you know, the blocks, the most recent blocks. Not only will it do that, but it will look for calls inside those blocks to a proxy contract on Ethereum. So basically, there'll be a contract on Ethereum called Internet Computer or something similar, right? And you can essentially, from your Ethereum smart contract, you can call the proxy smart contract and say, yeah, I want to call some internet computer smart contract. Here's the method name. Here are the parameters, right? Sorry, here's the smart contract ID. Excuse me. Here's the method name. Here are the parameters. And so you just make that call to the proxy. Now, what happens is, you know, these blocks, you know, Ethereum blocks being copied onto some internet computer smart contract, and it's validating them, and it's also looking out for calls into this proxy contract. But, you know, someone wants an Ethereum smart contract trying to call somebody on the internet computer, and so that internet computer smart contract makes the call, you know, and then obviously, as we know, it's going to get a result of calling the function on the internet computer, and then the internet computer through chain key cryptography can create Ethereum transactions, so you can send the result back by an Ethereum transaction, and bingo, you've got direct back and forth.
This is incredible. This reminds me of,
and no hubs, no bullshit, no cloud, all gone. So I think it's like, it's fitting in a way. But it's also, I think it's going to end up just adding massive value both to Ethereum and the internet computer, because the internet computer will be connected to a lot more use cases and DeFi and a pre-existing ecosystem. I actually think, you know, Ethereum's most powerful as a kind of DeFi settlement there, for a bunch of reasons. Ethereum's, you know, Ethereum dApps are going to be able to leverage the superpowers of the internet computer, which are things like, you know, serve web to users, you know, on-chain smart contract data that's 1 million times cheaper. I mean, you could create like a DEX, like you could have a DeFi system on Ethereum, right? And you could actually stick a DEX on the internet computer that processes, you know, 100 transactions a second, and actually serves like, you know, some user experience directly into browsers with end-to-end blockchain security that looks something like Poloniex used to look like. I haven't been trading crypto for many years. You could do that. You could put like you could have Poloniex on the internet computer. So I think, you know, the possibilities that become open up once you integrate these two blockchains are just limitless in themselves. I mean, it's going to be so exciting. So I don't know. For me, it's like personally very exciting thought because I was Ethereum really was. I was into blockchain, but I really got into it as a result of Ethereum.
I think that's a pretty broadly held perspective as well. I mean, Ethereum was the thing that cracked it open after 2014.
Yeah, but I mean, look, I got involved. I mean, it'd be on the sort of fringe of, I'd read this thing by Wei Dai in 1999 or something, and so I was using the Crypto++ library credit. So I sort of, some of the ideas were there. I just never had time to dedicate to it. But it was early 2013 where I really got in. It was Bitcoin that drew me into blockchain, and I soon became obsessed with it. But it was kind of Ethereum and this idea of a world computer that gave me the passion. And I spent many years just researching like applied cryptography ideas and consensus ideas and so on. And in the end, out popped the internet computer.
Hey, this has been fantastic. I don't want to use up too much of your time. I also don't want to give myself too much editing to do because I want to get this thing published immediately. Thanks so much. Let's connect again, Dom, to continue this discussion in the coming weeks. I'll get this thing published immediately.
Yeah, cool.
Awesome. Thanks so much. And it's just good to see your face, man. You're looking well.
Yeah, I am. I've been pretty sort of whacked out the last 6 weeks or 2 months, just the whole, getting to launch and then the sort of chaos after launch. And now you look at me, I've had like 2 or 3 days of actually slept. And I'm beginning to feel, and I think it's like I'm suddenly getting like relaxed and chill because it's like all of a sudden I'm like, wow, sleep. You feel.
Yeah, I can. I can only imagine.
It's like, it feels good. I like sleep. I've forgotten about it.
All right, mate. I'll let you go, and I'll talk to Sharon. We'll schedule another catch up at some stage.
All right, mate. Speak soon.
Take it easy, Dom.
Bye.